Okay, today we're going to take a look at the Code Interpreter Challenge presented by Topcoder. All right, so this is going to be an interpreter in Ruby that is, its main method is called BrainLuck. It's going to take in a code, and this code is just a string of operators in the designated language. And then we'll also take in the input, which is just a string that is going to be manipulated by the code. When we first start, it sets out the output value to a blank string, the opening memory location. The memory location is going to be where the data values or the input values are held and manipulated as the code progresses. Then we have a memory pointer, and this just points to the current location in the memory. The code pointer, which points to the current location in the code and its operator, and the input pointer, which points to the current location in the input. From there, I created a while loop, and it's just looping over the code itself, using the code pointer as the designator for the stopping point. Once the code pointer is equal to or greater than the code length, then the while loop will stop. Inside this while loop, I've set up a case statement. Now, the reason I use a case statement is because there were so many if and else if statements that needed to be used, and I like the tersity and simplicity of the case statement to set this up. Now, each operator has its own case statement, which will be described or which are described in the code itself. For example, the less than symbol is a shifter for the memory pointer. It will move the memory pointer to the left one position for each of the less than symbols that are used. If for some reason we are at the beginning of the memory, the allocated memory, then in order to move left, we have to unshift a value, a zero value, to open up memory in that area. The opposite of that, of course, is the greater than symbol, and the greater than symbol just shifts the pointer to the right. If when we get to the end of the allocated memory, we will add another zero value to that end of the allocated memory in order for the next value to be put in. The next statements are going to be the increment and decrement methods, and these are designated by the plus and minus symbols. These methods are just used to increment the numerical value at the particular memory location that the memory pointer is currently at. After that, we have our while loop designators. Now, according to the documentation on this code or this language, the opening bracket marker marks the beginning of a while loop. So this is just like a keyword phrase. So it's not really doing anything to manipulate the code. And as such, I did not put it in the case statements. I did, however, put the close bracket marker. Now, what the close bracket marker does is it tests to see if there are any nested loops within the code base. If it comes to a closed bracket marker, and during the time of the reading of the code block or the code string, we are counting the number of opening brackets or beginnings of while loops in order to keep track of the number of nested loops within the code statement itself. What the close bracket does is it designates the endpoint of a nested loop. If the bracket count is 0 on that nested loop, then that nested loop is completed and it moves on to the next block of code. If it's not completed, it will push the memory pointer back to the beginning of the while loop, which is of course designated by that opening bracket marker, and then start the loop over again, decrementing the count when the bracket is closed, or when the while loop is closed. Then we have our two read and write methods. Now the read method is designated by the comma, and what it does is it reads in a value from the input at the current input pointer, and it will write it to the memory location that the memory pointer is currently at. Then we finally have our write to output. Now if we go back to our top up here, we see that the output is just a string that is currently empty, and the write to output will take in the value of that input currently, the memory that has been allocated, and the current memory pointer. And what it will do with that then is it will write every character in the output, or it will write the character at that memory location designated by the memory pointer value as the character value of that ASCII number value. And then finally, we print output, or we return the output, which will be printed to the console. All right, and then with this case statement, I've just built in the functions that will be used by each of those markers. So the increment value takes in the memory and the memory pointer, and at that memory pointer location in memory, it increments by 1. If the value is 0, or it sets the memory value to, or the memory pointer at 0, if the memory pointer is greater than 255. Basically, it's looping over that values, because ASCII values only run from 0 to 255. If it goes beyond 255, it will just loop it back to that 0 value. The next method, of course, is decrement. It does the same thing, except it will reduce the number or the value at that memory location, and if the memory location or value is at 0, then it will loop back to the value 255 and set that as the value at that memory location. Again, here's the read byte method. It takes in the input at the input pointer and then just replaces the value at the memory location designated by the memory pointer with that input value. And of course, it's placing the ASCII number in that memory location. Then, to write to output, we take in an output value, the memory, and the memory pointer, and we write the character value, or the character destination, from that memory location into output. All right, so those are all the methods. Let's go ahead and see that it works now. So let's run the rspec first. So we'll run bundle exec rspec, and then the interpreter spec. We have 3 examples that were passed in and 0 failures. And then we can see what each of those values did by running the test method that I wrote into the code itself. So if we run the code, we can see that it prints off code wars with this designated code value and input string, code wars with this designated value and input string, and then it writes the character value of the multiplication of the character value 8 and 9 to the screen as well. So we can see that everything passes, and if there are any questions, please feel free to comment them or post them in the forum, and I'll answer them as soon as possible. Thank you.